Okay, so here you see the Triac board now, which has been completed. The original discussion was around the intermediate board, which I described in some detail earlier on. So now this is just showing you it hooks up to the intermediate board. In fact, if I zoom out a little bit, we should be able to see where I've got the intermediate board at the moment, and you can see that the pair of them are sitting alongside one another. What I will do now is just to demo the LEDs switching onto the Triac board. If I could just point out a couple of things, you will notice from the intermediate board, which again I did describe earlier, you've got the power in, obviously, which is on that connector just here. We have a 5-volt takeoff from this point, because the intermediate board has a 5-volt regulator on it, which you can see sitting just about down here somewhere. So we've got a 5-volt takeoff, we're taking that across, and we're taking it across and onto the Triac board, which is a 5-volt rail, and we've got a Ethernet cable, which is a standard pin for pin type Ethernet cable, which I've just coupled across to use to well, effectively I connected to the drains on the intermediate board of the FETs to pull down the 5-volt rail through our optos. So the opto isolators, and you'll see there's all 8 of them there. If I'll zoom in a little bit, we can see them a bit clearer. Perhaps you can see those functioning there, and we've got the LEDs associated with the web page, which I'm overlaying now, so you can see that. Not much else to describe on this Triac board really at the moment. It's partly completed. What I will do is couple it up to the some dummy loads. I'll put 8 loads on it, and where you can just see that working on the zero crossing. I might put some look at it on the scope as well with through the Variac and the isolating transformer, and we can see some gate drives and so on and so forth. But for the moment, you can see that it's working. So I'll just flip through the channels, and you can see, obviously you'll see it turn off the LEDs as we flip through them. So keeping an eye on one, and obviously watching what I'm doing on this one, we can just start with turning all the channels off. Channel 8, as I said before, was a motor snub circuit. Oops. And you can see that now is they're all effectively turned off, and I'll just flick those on so you can see them working. Channel 1, channel 2, channel 3, channel 4, channel 5, channel 6, channel 7, channel 8, and of course channel 8 is our motor drive. Notice I've left the outside temperature on this application because it's on the Onimex board, and I've decided to leave it on there anyway. It just gives me the temperature of the enclosure, which may or may not be useful. Anyway, it's on there. You can see channel 8, of course, flipping on and off, and if I go out a bit wider, hopefully you will see that this will be in tandem, of course, with the intermediate board. So that's that bit, and I'll just show this working with the dummy load next, so you can see that in operation, and perhaps then some waveforms if anybody's interested. Alright, cheers, thanks for watching.